Recording?
Yes, we are.
All right, awesome. So, hi everybody, welcome to the Cloud Development Basics workshop that I'll be leading. We'll be kind of going through containers, Kubernetes, and the cloud, which is just the basics, and we'll do a quick demo at the end as well. So, hello, my name is Esha. I had some technical difficulties today. But I am a cloud infrastructure developer on the infrastructure as code team at RBC. I was previously, for the last 2 and some years, was part of the OpenShift team. I joined that right out of school. I did an internship there and then started full-time on that team, and recently made the switch to the IEC team. A fun fact about me, I have a pet tortoise named Straw. He's sleeping right now, so he will not be making an appearance. And hopefully I teach you something new today. And obviously, if you have any questions, you can either send them here, or I can be reached at my email there. It's isha.abid@rbc.com. So let's get started. Today we'll be going through what is containerization, what is Kubernetes, what is OpenShift. That will be the cloud platform that I'll kind of be using to do my demo, and go through why we use it and how all these pieces kind of come together. So to get started, what is containerization? It's basically virtual machines were the first part of it. So if anybody's heard of what they are, they're basically the older way of launching and hosting applications. Virtual machines were on base infrastructure, so that would be things like your actual hardware that you put your hypervisor and the OS on and so forth. And so these servers are what host your virtual machines. And each VM has to run its own OS with any libraries and binaries that it's dependent on, as well as the application itself, which is not ideal. This could lead to a lot of issues, and one of the biggest ones is that because of all of these things, it behaves differently on your VM as opposed to your laptop. So the age-old, it works fine on my laptop, that you hear from every developer, that's kind of the issue that arises here. And this is where containers sort of enter the game. Their base layers are basically the same. They are also hosted on the same servers and the same underlying infrastructure. It does have an OS, but with a container engine on top. So I'll get more into what a container engine is and what Docker is. That's sort of the example that I'll be using here. But the good thing about this is that each application doesn't need to have its own operating system and stuff installed with it, which means that it kind of saves you on the resources. It makes it a lot faster for you to deploy your application and just patch and change anything on the fly. Doing all of that is so much faster with it. And so just as a quick comparison, right, VMs end up being huge because of all of these resource requirements, where containers kind of make it a lot more compact. And once you do have your container image, you can kind of deploy it anywhere, and it should act the same. So now going on to Docker. So Docker is a container engine. Basically, it's what sort of sequences and makes and builds your images. So your image is your application bundled in with any libraries and dependencies it needs into one thing. And so Docker is what is one of the most widely used things that helps you kind of build and package your images in your app all into one. And if you want to compare it to the VM solutions, it's kind of the equivalent of a hypervisor. So kind of getting more into how it works. The root of all containers is a Dockerfile. That sort of is what defines what's happening and what you're downloading onto the image and how it's being packaged. So it consists of layers in the way of commands. So for example, if you have a command to install something like npm, which is a packet manager, or to say change directory ownership or to just get your application started, like the run commands for it, all of that kind of lives in your Dockerfile. And then these files, once you build them, get compiled into images. And these images are basically what your container will look like. And they help build these containers. And once you have that, you can run it independently of your source code. So you'll have one version running while you can work on your source code. And once it's done, you can kind of put your next image on and run that instead. And so it's really quick to sort of change over and implement patches, as well as just keeping a version history of what you've done throughout. And you might be thinking, all of this just sounds too good to be true. There are some gotchas, but it's not all bad news. The only main thing is that data saved within a container or like into a container is volatile because it will only exist as long as the container exists. So if it's killed, the data is sort of lost. But there's a pretty well-known and standardized workaround, if you will, to this. This is where PVCs come in. PVCs stand for persistent volume claims. These are just the underlying layer of your storage, and they basically get declared as a space within your container, and then you mount it directly as a container. So anybody that's familiar with just basic command line, it's just creating another directory, but that one is related to your actual persistent storage. So all of the data is kind of kept safe there. And, just keeping that in mind, and, PVCs are best practice. So keeping all the best practices with you. Containers actually end up being some pretty cool tech. They're really cool because they allow you for easy application portability. They will let your app behave exactly the same going from like your personal computer to a cloud platform to deploying it on anybody else's computer. All of that, it will act pretty much exactly the same. And because containers run alone and they don't interfere with any of the other applications or any other containers that you've got going on, that means it's in a sandbox environment. So it won't really affect any of your other deployments. So even if a container does go down, all of the rest of your stuff is kept safe. If one thing goes down, it doesn't take the rest of your application with you. It will mainly just be the one service that's broken, which is really neat when it comes to having high availability, because if one feature isn't working, doesn't mean that people still can't use the rest of your application. And just as a quick TLDR, for anybody, the main three takeaways are that containerized applications use a lot less resources than VMs, and the libraries are self-contained within the container image, which means that you can deploy them really anywhere because that ends up making them OS agnostic. And all of this is really nicely managed by Docker. So that's how you would get started with containerizing your applications. Next, let's talk about Kubernetes. You'd be like, what the heck is a Kubernetes? I can't even say it. What it is it's just an open source container orchestrator. And it sounds kind of complicated, but if you think of an orchestrator, like say in a symphony, the Kubernetes basically just will tell your containers where to go. And it kind of saves you from having to manually deploy every container and check that it's consistently online and alive, and making sure that you have enough resources allocated to it, and if you need more replicas or less replicas based off of traffic, none of that has to be done manually if you're using Kubernetes. There's a handy little link there for people to kind of go to if they want more info on Kubernetes itself later. I'll have links kind of within everything. And I'll figure out a way to send this deck to share after. But yeah, so what it ends up doing is, there's an application lifecycle that, from when you've built your container to what Kubernetes does and how it deploys them as containers to a platform. So Kubernetes adds a lot of cool tools and features. So anything that has to do with monitoring your apps, making them secure, providing you with basic like monitoring tools like logs, all of that it gives you. But apart from those basic things, it will also take care of load balancing. So say you have a Kubernetes cluster with multiple nodes. This is what will deploy your containers to certain nodes and make sure that it's always available. It makes sure that, you know, it's always checking the liveness and the health of your application and so forth. So it's kind of a really neat base layer to do it on top of. And so, you know, quick TLDR here. I'll put a bunch of these TLDRs here just to kind of make sure you're getting the key takeaways. So for Kubernetes, it sort of is the automated version of managing your applications manually. It's added all of that in. It's mainly automatic for it to do. So once you've used it to deploy, you really don't need to worry about keeping tabs on it. It will alert you. It comes with monitoring features, and it will send you alerts if something is down. And because of this, it also orchestrates your entire cluster. And so if you have a multi-tenant environment like we do at RBC, what ends up happening is with a lot of these applications and app teams deploying to the same clusters, this orchestrates and manages where all the deployments go based off of node availability and things like that. And it also provides you with quality of life features for your application. The biggest one being health checks and liveness checks for it. And, you know, with Kubernetes, you're like, this sounds great. But the thing is, Kubernetes itself, you also have to add added layers of security. You can manually add extra features that you want. There's really no GUI for people to use, no web interface, right? And it doesn't really come with enterprise support as well. So bigger companies that would like to use it, or companies that want to implement it at an enterprise grade, tend to use some things other than just vanilla Kubernetes. And this is kind of where OpenShift comes up. So, you know, that's what's coming up next. And now you're like, okay, you've already told us about containerization and Kubernetes, and that was already a lot. And now you're telling us about OpenShift. What is this? It's one of many cloud offerings, right? It's Red Hat's commercially supported cloud platform. You might be wondering why I'm using it. It's because I was on the OpenShift team. It's what I've worked with a lot, and I think it's pretty cool. So that's why we're talking about it here. And it's largely used across companies, you know, based off of their requirements and stuff. They can have bigger and smaller clusters, and it makes it even easier to sort of deploy and keep track of and maintain your apps. It also provides you with a really nice looking CLI and a web interface. So if you're not familiar with Kubernetes, you can just kind of, or CLI and Linux, you can just kind of use the web interface and do everything through that, and it makes it much easier to navigate and deploy things on there. And the really cool thing is that you can still integrate any other CI/CD tools like Jenkins, etc., to help automate your pipelines and deployments even further. And the image that we'd seen before when we were talking about Kubernetes, you kind of only saw the main layer of the orchestration and management that Kubernetes does. OpenShift adds another layer of abstraction over top of that. So this will provide you with extra CI/CD tools. It lets you have a lot more control and like self-service features within it. You can implement in deploy automations, you know, for example, if you have different jobs that need to be triggered at certain times or things, you can automate all of that within like your deploy and build automations. And this just overall makes a developer's life easier and just a lot easier to keep track of all of your apps and have some ease of mind doing that. So TLDR here, it's Red Hat's enterprise-grade cloud platform. It gives you extra features and abstractions on top of Kubernetes to make the whole process a lot easier, and it can be automated further and integrated really easily with CI/CD tools. And so we're going to bring it all together. It'll be a bit of a break from me just spewing information at you. Hopefully you get to have some time to digest it all. And what I'll do is I'll provide you with some links here for future use. This is just to, if you wanted to replicate it, how you would get access to the Red Hat Dev Sandbox environment, the OpenShift CLI, and test source code. So that's on my GitHub. It's just, you can use really any basic Hello World app for it as well. And yeah. And really quickly, before I do switch over to my terminal and browser, I kind of want to go through a basic overview of what a Dockerfile is. So as I said, it's kind of the base layer of what all containers are built on top of. And it sort of is a set of commands that tell you how a container is set up. Some of the basic commands would be like add. So say you want a local directory copied onto your container. You use the add function, and then you would specify what directory you want to copy and where, and it does that. And so things like run, this is if you're passing in any Linux or shell commands for downloading. You put a run in front and then give it the command, and it knows to run and execute these as commands to, say, download libraries or dependencies within it. And the other main one that, or two main ones that you need to look at, the from statement should be the first part of your Dockerfile. This basically specifies the base image that you're going to be building your application on top of. And I'll kind of show you my source code and what the Dockerfile looks like there as well in a second. And then the user, that's the last one I'm going to go through with this list. It kind of tells the container what sort of user it's running as. So for example, you don't really want to run containers as root. It's not best practice, but you do need it to have root permissions to be able to download things. So what you would do is you would specify user root, do all of your downloads and anything else that might need root permissions. And then you would start your container off as an arbitrary user, say user 1001. So that's kind of what that would look like. So I will have this, I'll open up my source code really quickly here as well to show you what this Dockerfile does look like. So it's a pretty basic one. We're using a Python base image for Python 3.6, and it's a UBI 8 image, which is the latest one. We're copying from the local directory to the app directory within the container, and then changing the container working directory to that directory. And then really quickly, we run the pip install for any requirements that we have for the Python dependencies, expose it on a port, and then this command is the run command for your file or for your app to get started. So right here, it's just a basic Flask application. All it's going to say is hello world, pretty basic right here. And in the requirements.txt, we're putting in Flask because we are using Flask as just a backend framework, and we would like that to be part of this. So hopefully no more issues come up with this. I will pull up the source code here, and really quickly within my terminal, I will show you how to sort of get this. So I've cloned into, so here I'll start from the start. So I cloned into my code repository. I did a git clone of this. So just a quick, right here, you would copy the link, do a git clone within your local. And from here, you can really quickly see that it does contain everything that you see right here. Really quickly, we are going to go into the Red Hat environment for the sandbox right here. I have already sort of logged in, so it kind of auto logs me in. What I will do is copy the login command here. This is so that I can log in via my CLI and be working on the same thing. And you'll get to see sort of how it plays in and what it looks like going through. So I'll log in here. It will give me the login tokens. All I need to do is copy this command. I'll bring this back up actually. I will put this, I will put these side by side so that it's easier for you guys to see what I'm doing as it's happening. And so really quickly, I'll just paste this in here and it logs me in and it says that I'm right here in this project using the dev one. And we'll make sure that we are in dev here and it looks good. And so we are in the directory here. I will kind of show you a local build. So basically what that means is what it looks like if I build and run it locally and then how to put it on OpenShift. So if I do a Docker build and tag it workshop and let's double check this. Okay, this looks good. I'll just really quickly double check that my Docker is running and restart it. Sure. Just to kind of make sure that it's running and it's all good. And we can check that if I have my old one, no, it's not up yet. I'll wait for this to turn green. And then that will mean Docker's up. And the cool thing about Docker is while we're in here, it'll show you any of the images that you have successfully made. So for example, this is my older one that I did as a test. So this will be here and available for me to use as well. So let's try this again. And it's not working. That's fine. We can actually, this will be great. We can build it on OpenShift and see how that goes. So we'll do OC. And here I will pull up really quickly the keynote commands here and sort of play it in Windows so that you guys can see it as it happens. And you have the commands there at the side. And play. Cool. So really quickly, we're already in here. We'll do an OC new build and sort of go from there. Cool. So OC new build, we'll call it demo. And basically what this command is doing is you're specifying that it is a new OpenShift build. You're using the Docker strategy to do it. The code is located within your local directory, so the dot specifies that that's the directory you're in. And you'll give it a name, so we're going to call it demo, and you're going to give the app a label. So this -L adds the app label to it. So if we do this, fingers crossed it goes well. And you'll see that it starts kind of giving you all of these commands and outputs where it's building everything. So it says the image stream and the build config is created, success. And oops, wrong way. And you can kind of compare the outputs here, see that, yes, this is what it's supposed to look like, and go on. So from here, we'll go to the next one. Next command, we'll be doing a start build. So what we just built, we'll be doing that, but we are specifying that it's still from the current directory, and you're going to be following what you did earlier. So we do OC start build right here. And here you need to make sure that whatever name you gave it earlier, so we did call it demo, so we'll change it here and hit enter. And it takes a couple seconds because it is uploading everything, and it's a fairly large output, so it'll kind of go through and do that. And you can kind of see these things popping up here. I believe if we go into builds and look here, so the build command that we'd run created this build a minute ago. So this is how you see it kind of happening real time within the UI as well. Here it's just currently pulling the image. So the image that I'm talking about is the Python one. It pulls that first and then goes through all these steps and sort of creates the image to use on OpenShift here. Give it a couple seconds. And while this is happening, I'll kind of start talking about what happens next. So while we are building all of these, and here you can see it going through all the steps. It tells you what step of the Dockerfile it's on. While this is happening, this doesn't automatically sort of start the application. It just builds all of the underlying stuff to it. So as you see that it's built and pushed the image for your entire app together right now. And so now that we have all of that, we'll do an OC new app. What this does is this will actually initialize sort of the deployment. And we'll do, I spelled it wrong. OC new app and And so right here, you see that it says that you can do OC status to see what it looks like, and you can start exposing a route. So right here, you see that there is something that's appeared here. This is the actual container for your app. It'll tell you that it's running and that the build is complete and stuff, and what ports it's at. And it says OC expose service demo. What this will do is this will actually create a link for you to click. So this creates the route where you can see the output. So if we do OC expose route, you see that this thing appears right here. And if we click it, we should get a lovely hello world here. So the route is what will actually take you and expose it to people for them to be able to use it. So it creates a URL and everything. And so right here, we can check that, we did this, we got the OC exposed. There is one other way to get this route. So obviously the UI is really nice, but if you are a terminal wizard, you can do OC get route. And right here, it will give you all of the routes. So for example, the demo one is right here. So you can also copy paste it and sort of see it from there. But yeah, this is a very quick, I know kind of very dense introduction to cloud basics on how to build, containerize, and deploy to cloud. So this is where I guess I'll stop sharing and open it up to questions.